let's continue with our implementation. Remember that so far we only have implemented the k-fold cross-validation method. So let's add another one. Let's implement now the random subsampling. We're going to add another class here called random subsampling. The init method is very similar to this one, so I'm going to copy it. The main difference is the parameters. Right here is we're going to have, let's say, number of rounds, and we also need the training percentage. It might be 80-20, 70-30, or whatever, so let's call it train percentage. And let's assume a default of 80%, for example. Okay. The rest is the same. We're going to need the same two methods to get the splits and the prediction and real columns. And here we're assigning the variables. So let's start with the get splits methods. So we need the indexes. Let's use this variable to save the percentage for training. And let's initialize the splits. So we're going to have B splits for B rounds, and in every split we're going to have a training and a testing section. So let's use another dictionary. Both are going to be empty arrays, are going to start as empty arrays. Let's make sure they are integers. So this will be repeated num rounds times, right? What we need to do is, like, on every iteration, for example, let's assume that the training percentage is 0.7 or 70%. So on every iteration, we are going to extract a random selection of 70% training points on every class. So we are going to iterate over the classes and over the folds or rounds, right? So why we iterate on every class? Because we want to make sure we have the same amount of classes on every round. In other words, we are going to make a stratification, meaning we are going to extract the same percentage of training cases on every class. Okay, so for B in splits dots keys, here where I get all the classes. So let's get again a slice of the class, meaning all the indexes of the specific class. And now we update the splits. So the training part is going to be, let's assume we have a selection, right? The selection is random.choice. We are selecting out of the slice of the class how many the training percentage times the length of the slice, right? We need to make sure it's an integer. We want to do it without replacement, right? Okay, so this is the selection for this specific class. Now we need to add that selection to all the selections we are doing over the classes. And for the test part is similar, but instead of selection is going to be exactly the opposite, what was not selected. sure this is an numpy array. And that's pretty much it, right, for this function. Okay, so let's try this before we continue. Now we need to import here the random subsampling. Let's try this one instead. Let's use 80% better. And this is not going to work yet because we need the other methods, the prediction and real column. But it should. Well, let's implement that method now. It seems that it's working, the previous method. So now we need to implement the real columns. Let's initialize exactly as here. Okay, so now we are going over the splits. And we are going to fit the model in the training part and then predict in the testing part, right? So where we are fitting in our data, indexed in our training splits. Let's get some help here with this variable self.splits of b train. It's going to be indexes in IDX and only with the features, right? We're feeding with the features. That is the training, the input, and the labels is going to be self.data index again in the same indexes, but now only the class. So those are the labels for training, right? So after we feed the model, now we need to get the predictions. We are going to predict let's now use again this variable, but now with the testing part. Again, we are predicting over the features. We need to make sure we are keeping the previous predictions for all the other classes, right? I'm sorry, all the other rounds. Okay, and the real column is similar. This is just the real labels. So it's going to be says the data indexes also an IDX, but just the class column. So first we get the training indexes, we index the data for training, and then we get the testing indexes, and now we index the data on those indexes for prediction. We get the prediction, and then we keep the real column with the real class. So let's try now this in our notebook. Okay, it seems that it's working. Now let's do the following. Let's iterate over different possible methods, right? So let's use some methods list that will contain the method names. Let's start with this one. Actually has to contain two things: the method name, so we're gonna need a dictionary better, the name of the method, and the parameters to be passed to the class. So let's use tenfolds in the case of the cross-validation, and now random subsampling, where the parameters are going to be the number of rounds and the training percentage. Let's use 80% here. Okay, so we're going to add another layer of iteration. Now let's generically call the name of the class. So instead of calling here the random subsampling, we're gonna call the method class. So this will change depending on what method we are on. How we do that, we can extract all the list of imports from the classifier performance class and select the one that matches the name we want. So we do that with the getAttribute method. Here we call all the imports specifically from the file classifier performance, and we get the one that matches the name of our method. So the good thing of this is, like, using this we can call a generic class here, right? And of course we need to modify the parameters. These need to be exactly the parameters of the method. So it's going to be methods of method, but specifically the parameters dictionary. And the title now should include the method name. Okay, so we are going to print the method of validation and the classifier. We are going to be changing the classifier, sorry, the method here. We are calling generically here the method, and I think that's it. So now it's processing the nearest neighbor classifier for the K4 cross-validation. Also now the decision tree classifier for the K-fold cross-validation. So finally the support vector machine, and now we're starting with the random subsampling. Okay, so it seems that it's working. So now if you want to add more validation methods, you just need to go here, you implement another class, right? Mostly with these two main methods, and then you go here and add the method name with the parameters, and that's it, because here automatically your method is going to be called and it's going to be tried with all the different possible classifiers.